All right, number 24 on the final review, that is an 80 kilogram person standing on a bathroom scale with a 75 centimeter pendulum oscillating, and then you're supposed to find the period when the scale has different readings. So when the scale has different readings, that is going to help determine like the apparent value of, quote, G. So standing on a scale measures gravity, basically. It's the normal force acting upward when you have a force acting down. So if you have a force of gravity of 750 newtons and you are an 80 kilogram person, that means that the apparent value for G isn't 10 like it's supposed to be. So when you do that math to end up getting the apparent value for G, you do 750 divided by 80, and that's going to get you a G value of 9.375. So that just means that in this situation, we end up with a G value smaller than what it's supposed to be. So the elevator is moving in a particular direction. I'll let you figure that out. So 2 pi times the square root L over fake G is going to give us the period for that particular situation. So when we have this, we end up with a time period of 1.777 seconds. So that's going to give you the period when the apparent G is 9.375. So then for part B, we end up with a value on the scale of 800. Now 800 divided by 80 is going to give you 10, which is the value for G that we usually use. So that's going to be our G value for this. So this is technically an elevator that is not moving because the value for G is the same thing. So 0.75 divided by 10 is going to give us our value. We're going to end up with 1.721 seconds as our period. At the third one, we end up with a force value of 850. And 850 is higher than the 800, so that means we're going to end up with a G value greater than 10. And this G value is going to be 10.625 meters per second squared. That's going to be the value that we experience in this particular elevator at this time. Plug it into the equation, 2 pi times square root L over G, and you end up with your time period for this of 1.669 seconds. So all of these time periods are different. They're not different by a lot, because if you were to round them all, they basically are 1.7 every time. But what you'll notice is that when the fake G value is greatest, or when it keeps getting larger, you end up with a smaller time period. Part of that's because the force is directly related to how much it can swing. So a larger G means you can have more force.